All right, good evening. So one of the last problems we're going to talk about, okay, is something called Simpson's rule, right? It's a numeric integration technique, and I think for the people that take this class in particular, this is a really an important little technique to have up your sleeve, because most of the stuff you do in a lab that gives you a printout, it doesn't give you a nice like 1 over x squared or logarithm of x. They just print the dots, right? And then they say find the integral or figure out the area under the curve here or whatever. You got a bunch of dots to stick together, and how you're supposed to get an area under the curve. And Simpson's rule is that answer. Okay, so this is how you do numeric integration. This is a slick way to do the numeric integration. There are other ways. Okay, so I provided you a formula, so that's inside of the quiz. All right, don't memorize this thing. Just know that it exists. And if somebody ever asks you to integrate something, like I do not know that integral, there is nothing wrong with figuring out. Well, I'm taking an integral from A to B, right? And then you're going to there's like how big do you want these? They don't always have to be 1. They could be 0.1. They could be a half. Okay, armed with a spreadsheet, they could be whatever value you want. Okay, and you just have to plug the numbers in order to get what's going on. Okay, so that's what Simpson's rule is used for. And like I said, you don't even need a nice analytic that's like a formula function in order to do this. I'm like, well, here's the integral of like sine squared. You say, greatly, I've never done that. But you can graph it and you can plug in some values and say you have to go from 0 to 0 to pi or something, or whatever. But you can come up with some values, integrate using Simpson's rule, get an answer. It's not going to be exact, okay, but you can get a number that's kind of close to what you're looking for, and without having to do any fancy integration techniques. Okay, so this is a very useful thing to be able to deal with. Okay, so what about this case? We don't have a formula. Okay, all we have here, right, is -1s. We just have some values here. And like I said, the one that I gave you on the quiz looks very similar to this. I don't have the little dots here. So I a couple of years ago, I had this dude got out a ruler and measured like the distance to where it didn't quite meet the thing, and they don't do that. Okay, if it's close to an intersection, I met the intersection. Okay, it's just my ability to use Excel is a little lacking, and Excel is a little difficult to force into compliance. So let's just get started with this. All right, so we have b minus a over n. Okay, so that's one thing we need to deal with. In this particular case, a is -1, b is 5. Okay, so we're going to go ahead, we're going to hit b is equal to 5, a is equal to -1, 5 minus -1 is equal to 6. Okay. And then we have 1, 2, 3, 4, 5, 6. So each of the values here, so we have n equals 6. We have 6 over 6. Okay. B minus a over n equals 1. Now we have 1/3 times b minus a over n. Sometimes this piece here, this is just called delta x. Okay. But that's okay. So we're just going to have delta x over 3. It's fine. Okay, so 1/3 times this, 1/3 times this piece here, that's equal to a total of 1/3. So in the end, once we've gotten all this stuff done, we're going to divide by 3. Okay, multiply by 1/3, it's the same thing. Okay. So let's just go ahead and type in. Okay, what's our f of x of 0? What's our f of x of 1? What is our f of x of 2, f x of 3, x of 4, x of 5, and let's just see where that ends us, okay? So here we're going to have, what is f of -1? Well, that's 4. Okay, we're just going to, okay, if you wanted to make a table for this instead, that would probably be better, but there we have it. Okay, f of x2, that would be 0, right? Or f of x1 rather. So at x0, that's going to be 3. Okay, x2, there's 1, or 0, 1, 2, that's going to be 2. Okay, so here 2. Go up 1 more x, that's going to go back up to 3. Okay, and we're going to go all the way up to, no, it isn't. F of x2, oh yeah, it's 3. Okay, next one up is going to be at 6. Next one after that is, again, f4, that's going to be all the way up here at 6. And f of x6 was going to be f of 5, which went up to 4 again. Okay. Okay. So we have our things laid out here. So now we're just going to add them up. Okay, so we need f of x of 0, that was going to just be 4 plus, okay, here's my coefficient. We need 4 times, okay, so 4, we'll just do it this way, 4, 2, 4, 1, 2, 3, 4, 5, and then we need a 1 for the 6th one. Okay, this had a 1 next to it, 1 times. All right, and then the values that we put in here, okay, we have 4 times 3 times 2, okay, times 3 times 6 times, oh, this should be, double check I did this, 4, 2, 4, I messed up, should be a 2 here. 4, 2, and this should be 4 and then 1. Okay. So notice, like, that's how I do it screwed up, because the ending has to be 4, and then finally the last one has to be a 1. So it's 4, 2, 4, 2, 4, 2, 4, 2, 4, and then 1. Okay. So just try to remember that pattern. Again, it's going to be on here, but make sure that before the last one, there's a 4 times something here. Okay. So let's go back to blue. Okay. So 4, 2, 4, 2, and then that was a 6, and then we have a 6. All right. Hey, that's a book. It's not yours. Okay. And then a 1 times a 4. Okay, remember that this is all times with third. Okay. So we'll hold the third out to the end here. Okay, so we've got 4 plus 4 times 3 times 2 times 2 plus 4 times 3, 2 times 6, 4 times 6 plus 4. Okay, and we're just going to add these up. Okay, so let's see, we have 1, 2, 3, 4, so that's a 12. It's 112, 2, 3, 4, that's 48. Okay, so that takes care of all of my 4s, all of my 12s, and we need plus 24 here. Okay, so that's going to be, it looks like 72, right? And then we're going to multiply by 1/3. Okay, 1/3 from 72, that is going to be a total of 24. like every day's textbook problems, this comes out to be a perfect little number. I don't think mine does. Okay, it might, but I don't think I was that careful about it for you. Okay, and you're not insane with the decimal places, but it may have a little bit. Like this may not work out to give you a fraction. It'll give you a nice number, probably be a fraction. Okay, but that's how you deal with Simpson's rule. Okay, I don't know if we want to do another one. Okay. And again, it's when you're given homework assignments, when you're doing like quiz questions, it's very common that we're going to do subintervals with just one unit here. Okay, if you have access to a spreadsheet, these could be whatever number is going to be convenient. Okay, but there we have it. Okay, so you remember how to integrate like 3 to the x? No? Okay, let's see if we can try it. Okay, we're going to integrate numerically 3 to the x, -2 to +2. Okay, and maybe we'll round to 2 decimal places. We won't round to a whole number. Okay, we may not have to. No. So same thing here. All right. So we're going to go from -2 to +2. So we have integral of -2 to +2. F of x dx. F of x in this case happens to be 3 to the x. Okay, we'll do it analytically as well, but for this one we'll go ahead and do that. So we're going to have b minus a 2 minus -2, okay, over n, and has to be positive. It has to be a number, or a positive, or an even number. Sorry. It looks like 1, 2, 3, 4. That's what they want. Okay, so n was equal to 4. We have 1/3 times all of that. Okay, so our delta x is 1, so we have 1/3 times 1. All right. Now, what we're going to do is we're going to make a little chart here, and we're going to come up with. And you can make the chart lengthwise or longways. It doesn't really matter. Okay, but we're going to put in our x of -2. Give me a moment. I think she's going to make an appearance tonight. She's a little upset. Okay, she doesn't really like to be picked up. All right, so I'm not going to force the issue on her. Okay, so we have -2, -1, 0, 1, and 2. Okay, so this is 3 to the power here. It's 3 squared. We'll come over here for an answer. That's 9. 3 to the 1, that's 3. 3 to the 0, that's 1. 3 to the -1, that is 1/3. We'll say 0.33 because it's a numerical thing. And 3 to the, okay, well, what were we on here? We were on 1/3. We're going to call that 0.33. Okay, and 3 to the -2 is 1/9, which is 0.11. Okay, I mean, it's 1.1 repeating. We're going to keep going here, but they only wanted integers, so we'll stop with that. Okay, so now we're going to do, okay, this could be the coefficient. Okay, this could be the coefficient. So this is this, and then we can put in the coefficient here. So this is 1, 4, 2, 4, 1. Okay, so it's f of x 0, 4 times that, 2 times this, 4 times this, 1 times this. Okay, so let's go ahead and say, well, let's take our coefficient times our f of x. Okay, so 1 times 0.11, 0.11. 4 times that, that's really 4/3, so it's 1.33. 2 times 1, 4 times 3, 1 times 9. Okay, and then we're just going to add these up. Okay, just going to add these up. So hopefully we'll get something here. So clear the probability stuff. So 9 plus 12 plus 2 times 1. Okay, plus I'm going to go ahead and type in 4/3 because I don't really quite know what we're going to end up with. Plus 1/9. Okay, and we'll see what happens. Okay, it looks like we have 24 and 4/9. Okay, what's this? We could do math. Go to take it to a fraction. So this is 2/20 divided by 9. Okay, why would you do that? Like, well, remember this 1/3 out in front? So this is 2/20 over 9 times 1/3. So I was hoping that something might cancel, but it doesn't. Okay, so we're just going to say times 1/3. Okay, and then we end up with 8.1. This 8.148. 8.148. So, like I said at the beginning, we'll round it to that. Okay. Now, how do we come up with? Sorry about that. How do we actually integrate this thing? Okay. Do you remember that rules of logarithm, right? That e to the natural log of a thing is just the thing. You can try it. Okay. E to the natural log of 3 will be 3. E to the natural log of 10 is going to be 10. Okay. So we have 3 to the x. Let's call 3 equals e to the ln 3 raised to the x power. Okay, 3 to the x. This is a 3 raised to the x. What do we do when we have, right, an exponent raised to an exponent? We multiply them. So this is e ln 3 times x. And if I want to integrate this, okay, well, we could do a u substitution, right? Let u equals ln 3x du is equal to ln 3 dx. Now, I don't have a random ln 3 walking around here, so what we're going to have to do is we're going to need integral. This is a to b here. Okay, we have 3 ln x, or ln 3 rather. 3, what am I doing? Okay, ln 3 x dx. So what I'm going to do is I'm just going to add an ln 3 here. Now, I can't just go around doing that. So we're going to go ahead and divide by ln 3 as well. Okay, because they'll cancel. Now I'll make my substitution. So this is 1 over ln 3 times some kind of an integral here. And we have e to the u du, don't we? Because this is now du. Integral of e to the u du, e to the u. So we have 1 over ln 3 e to the u. What was u again? U was natural log 3 x. Okay, so we have 1 over ln 3, and we have e to the ln 3 to the x. What was e to the ln 3 again? That was just 3. It's a terrible n. Okay, so this is 1 over ln 3 times 3 to the x. Okay, there is a formula. You probably learned it different in Calc 1. I never memorized this one, but once I learned this, it became much less mystical. And it was like, now I'm justified for not memorizing it, because to be remembering this was easier than memorizing the formula. Okay, if you're still carrying that formula around from Calc 1, congratulations, but most people don't. So we have from a to b, right? We're going to go from -2 to +2. So we have 1 over ln 3. Okay, and we have 3 squared minus 3 to the -2. Okay, so we have ln 3, and then we have 9, 3 squared minus 1 over 9. Let's see what we get. We're going to be a bit off because delta x of 1 is It's too gross. It's too big. Okay, and then divide by 3. Okay, 8.09. I mean, for what we have, what we did, okay. Of course, if you're going to let your delta x get smaller, it's like it's a half or 0.25 or something, you're going to get a lot closer of a thought. But that's how you do Simpson's rule, okay? And I think that was everything I really wanted to talk to you about. So yeah, if you need another example of another problem, just tell me what type of problem you want to see. And again, this is for my class. It's not for like random YouTube things, okay? But if you want to see like another example of for final exam, like let me know, okay? And I'll put this on there, okay? There's so many other. If you're just looking for like random integral help, black pen, red pen is awesome. But there are plenty of others that can do. Okay. So, but if you're one of my students, please ask. I'll make sure I do another video like this talking about like how to do this thing or not. All right. So with that, I wish you good luck on the final. I know you guys can do it. Okay. I didn't pick the hardest problems. So you should, if you followed through with most of this, you'll be able to do okay. Oh, there's one more. I'm just gonna leave this as a note. I won't do one. Total derivatives. All right, it's delta. It's this. And if there is a z, there is a, okay. Keep going. Okay, that's the total derivative. You'll probably recognize the problem when you see it. Okay, but that's what you do with it. Okay, I'm gonna let you go. All right, thank you.